Okay, so just a couple of ground rules. Sorry, a couple of ground rules before we start. We're going to declare that A and B are going to be positives, but not 1. Okay? Positives, but not 1. And as far as M and N go, if you see an M or an N throughout this lesson, they are positives. Okay? Both positives. Okay, so let's look at this first statement. Why is log base A of 1, 0? Why is that? Well, if you understand what the question's asking, it's saying what power of A creates a 1? So it's like asking what power of A makes 1, and the answer to that question is 0. The 0th power makes 1. Okay? And this one's saying what power of A makes A. So I'm looking at the second one now. The answer to that is the first power. What power of A makes A? The first power. So that's where these two rules come from. Pretty straightforward. Let's see if my little highlighter works. So that one goes with that. See? And then the other one, can I change my color? Yes, green. Oh, it's still yellow. I don't know, that didn't work. Okay, so anyway, there you have it. Does the eraser work? Barely. Okay. Let's go on to the next one. What does it mean for us to find A to the log base A of M? What does that even mean? Okay, so the answer to this is evidently just M. But why? Why is that? Well, remember what we said earlier. We said that 2 to the x and log base 2 of x are inverses. We said that yesterday. Isn't that true? And we also have a rule in math that if you take an inverse function and you compose it into the original function, you actually get x. Right? The same is true if you compose in reverse. If you plug the function into the inverse function, you should get just x. Examples of this are like if you do the cube root of x and then cubed. What's the answer to this? What does this turn out to be? X. Right, no surprise there, right? Well, to the trained eye, this is the exact same thing. A to the log base A of M, that's just redundant. The answer is M, see? You've got basically this thing plugged in right here. So imagine taking 2 to the log base 2 of x. That would just mean x. Okay? And conversely, if you plug the 2 to the x into the log, it would cancel out. So this next statement here, you can cross out the log base a and the a to the, leaving you with just r that survives it. Okay? Okay, so for example, if I wrote log base 3 of 3 to the 5th, the answer is 5. If I write 3 to the log base 3 of 5, the answer is 5. The log is undoing the exponential and vice versa. All right? Let's go on to the next rule. The next 3 rules actually are ones you'll use a lot. Okay? So you can circle them. Rules 3, 4, and 5. Okay, so these 3. These are like the 3 amigos. Okay, you guys probably believe rules like this. X squared times x cubed equals x to the 2 plus 3. You probably believe that. You could probably even explain that to a 5th grader why that's true. You probably believe that x cubed over x squared is x to the 3 minus 2. You probably believe that, right? You probably believe rules like x squared cubed equals x to the 6th. You might even be able to explain that to a child. Well, these 3 rules are the inverse rules for those. So if the logs have if the exponent rule has rules like these, then the log rule should have rules like these. In fact, these 3 come from those 3 respectively. I will not show the proof why this means this, and this means this, and this means this, but know that that's kind of where they came from. The basic rules of exponents create these new basic rules of logs. Okay? So for example, if you ever see something like log of 5x, you can actually write that as log of 5 plus log of x. See? Or if you ever see something like log base 3 of 5/7, you can write that as log base 3 of 5 minus log base 3 of 7. Or if you ever see something like log base 2 of 4 cubed. Let's not use base 2. Let's use log base 7 of 4 cubed. If you ever see that, you have my full permission to just move this 3 out front. So it's 3 log base 7 of 4. Just move the 3 out front. That's actually what this rule is letting you do. It just has a little r up here, and now the r's up front, see? So how do you remember these 3 rules from your Algebra 2 class? Okay, most people tend to at least remember one of them or more. Okay. The next rule kind of stands alone. So let's look at that one. Thank you. That's very helpful. Okay. Let's go to our next rule. The next rule is just saying that, listen, remember when I gave you permission, when you had like 2 to the x squared minus 3 equals 2 to the 4x, or maybe this one, this has a solution. And we crossed out the 2's, remember that? We just kind of felt permission to do that. Well, I'm giving you permission to do that if you see a log. So if you ever see like log base 2 of x squared minus 1, and then this is equal to log base 2 of 2x or something, feel my full permission to do this. Okay? That way you can just solve it as x squared minus 1 equals 2x, if that even has a solution. Okay? Do you understand? You can cross out the logs, as long as they're the same base, of course. And then the next rule is actually kind of hard to prove. It would take almost a full page to prove this, or if I wrote it in my big handwriting on here. And so I'm not going to do that. But the change of base rule gives us permission, if we don't like the base we've been given, to switch it over and use something else. For example, let's say you had your calculator out and you wanted to find something like log base 2 of 5. Well, there is no log base 2 button on most of our calculators. Okay? So what you can do is instead, you can take the 5 and the 2 and you can rewrite this whole thing using whatever base you want, which is kind of cool. So I personally like LNs. Those are my favorite logs because I own a TI-89 and Carly owns a TI-89 and a couple of you own a TI-89, and there's no log button. There's no LOG button anywhere. You can type LOG. You can find it in the catalog.
It's Diamond 7.
Diamond 7.
Yeah.
I never knew that. Okay, but I've been using LN for a long time. I just type LN5 over LN2, and it gives me the same thing anyway. Or if you like the LOG button on your calculator, you can use LOG5 over LOG2. Both of these give you log base 2 of 5, which is like 2.32, right? Okay, so I'm giving you permission to use this little formula if you ever feel like you don't like the base you've been given. Okay, let's go on. Nice music. Okay. This eraser takes a long time. All right. Simplify. These ones are really easy to simplify. The first case we have is 2 raised to the log base 2 of something. In other words, this just cancels, and the answer is pi. And the next one is log base 0.2 of 0.2 to the something. This cancels out, giving us negative root 2. And this next one might not look like it, but if you remember that an ln really means log base e, this problem just comes out to kt because the log base e and the e to the undo each other. Okay, so I'm going to try to help you understand why that works just real quickly, okay? Imagine typing this into your calculator. What are you asking the calculator to do? Well, the calculator is first going to try to find the power of 2 that makes pi. And it's just gonna come up with something like 1.4, or 1.12, I don't know. So what power of 2 makes pi? 1 point something, okay? And then the next question it's gonna answer is 2 to the 1.4 is what? Well, the answer is pi. You just asked the same question in reverse. We're saying, hey, what power of 2 makes pi? The calculator answer is, okay, what power, what would happen if I put that on a 2? You're gonna get pi. Just ask me that, see? So this is what I'm doing in Excel, giving us these simple answers. Okay. Even if you don't fully grasp that, at least know that inverses undo each other, and we are dealing with inverses here. Okay, let's go on to our next one. This will allow us to use one of our Three Amigos rules. Okay, so hopefully you circled those 3 rules in the middle there. This one says write as a sum of logs. So I noticed that this is a product, right? Notice that you basically have a product here. Where's my pen? Give me back my pen. Okay. Oh man, I can't write. Piece of junk. Pen. Can I use this pen? No. Okay, pen. Now I can use a pen. Oh, I like the little tools at the top. That's nice. Okay, so let's use the pen. Notice this is a product, right? It's 2 different things multiplied. So according to one of our log rules, we should be able to write this as a sum of 2 logs. So we could do log base a of x, that's our first log, plus log base a of, and then my other factor looks like a square root of x squared plus 1. There we go. And I did it. It said write it as a sum of logarithms. I did it. But then there's this other set of instructions that says express all powers as factors. What are they talking about? Well, isn't it true that the square root of x squared plus 1 can also be written as x squared plus 1 to the half power? In other words, I could write this as x squared plus 1 to the half power. Same thing as square root. Well, our third rule of the Three Amigos rules allows us to bring this half to the front. See? So we could actually work with this a little bit more. We could bring the half to the front before we call this fully simplified, okay? You might remember doing this. It kind of sticks in people's brains. The first time they learn it, they tend to not forget it for a very long time. But here's a refresher, okay? Okay, and then somebody asked me earlier, what can we do with this x squared plus 1, this log x squared plus 1? Can we split that up? And the answer is no. We don't have any rules that say what to do with a log of m plus n. Like there's no rules up there in the instructions. So we'll just stop here. You're better off not going too far, right? All right, let's go and erase this. Okay. Next is this one. Okay, you can see the fraction look here. This fraction look reminds me of the second rule in those Three Amigos rules. And a fraction makes subtraction. It rhymes. Fraction makes subtraction. So let's just make 1 log for the top. These are ln's. And 1 log for the bottom. And they're subtracted this time. So a log of a quotient is a difference of logs. And now we can bring down the 2 and the 3. Nothing I can do about that x minus 1, though. I'll have to leave that. Okay, the next one also is a fraction. So it makes a subtraction. This time it's log base a. There's your numerator in the first log. There's your denominator in your second log. And I noticed that we have a product. We've got a product going on. So, see how this is a product of 2 things? We should split this up before continuing. So why don't we write this as log base a of x cubed plus log base a of And let's write the x squared plus 1 to the square root. Let's write that as x squared plus 1 to the half, if you don't mind. And then we can bring down the various powers. Looks like we're going to bring down a 3, a half, and a 4. So here's your final answer. 3 log base a of x plus half log base a of x squared plus 1 and minus 4 log base a of x plus 1. Final answer. Okay, so you can open up one logarithm and make it into multiple logarithms is the idea. Okay, we can also do that in reverse and take multiple logarithms and collapse them into one. Okay? And I'm going to go ahead and add a part D to this one because there's a special case that I forgot to put in my notes. And that's if you have, let's say, log of 3 plus log of 5 plus log of 2 plus 6. So we're going to talk about that problem in a minute, okay? Okay, but for part A, you're welcome to put the logs together, but only if the coefficients are 1. So see how there's this 4 right here? You can't have that there. You've got to move that 4. Now a minute ago we were bringing powers down to the front. We also have permission to bring these up. So I'm going to actually move that 4 up to where the 3 exponent would be. So first thing I'm going to do is rewrite this real quick. Like that. And 3 to the 4th, of course, is 81. So I basically just can collapse this into a single logarithm. It's 7 times 81, 567. So the answer is log base A, 567. That one's done. Okay, and then on B, same thing. You can't have this 2/3 here, unfortunately. So you're going to have to move it. We'll just put it up here as a power on that 8. So our first rewrite gives us ln of 8 to 2/3 minus, and this is kind of silly, it says 3 to the 4th minus 8. That's just 73. I'm not sure why it's written as 3 to the 4th minus 8. But let's go and write that as 73. And do you guys know what 8 to the 2/3 means? Yeah, it means square the 8 and then cube root it, or cube root the 8 and then square it. Either way you get 4. So this is really just ln 4 minus ln 73. And how do you write that as a fraction, class? ln what? 4 divided by 73. So you can write that as a log of 1 fraction. Okay, and then the last one, let me write that answer over here. I need the space. Okay, this last one I kind of saved for last. The first 3 logs collapse easily because you've got log of 3 and log of 5 and log of 2. So basically you're just going to make it into a single log. These are base 10 logs, you can tell. What's 3 times 5 times 2? What's 3 times 5 times 2, guys? 30, right? Okay, so the first log is just simply log 30, but what am I going to do with this 6? What am I going to do with the 6? It said to put everything into a single log. I've got to put the 6 in. Well, the 6 wasn't really a log, but isn't it true that 6 is basically log base 10 of a million? Look. Log base 10 of 10 to the 6th. That's the same thing as the number 6. Right?
Yeah.
This is 6. What power of 10 makes 10 to the 6th? 6 power. So I rewrote my 6 as log base 10 of 10 to the 6th. And now I can collapse this together. They're both base 10 logs. And I get whatever 30 times 10 to the 6th is. So I'll just write that as 3 times 10 to the 7th. Okay, so my answer is log of 3 times 10 to the 7th, or I could just write 30 million. That's the answer. Okay? All right, the next one, we already kind of practiced this, but we're going to just type this into our calculator. In order to get log base 2 of 7, we actually type it as ln 7 over ln 2. So ln 7 over ln 2, or you can use the log button if you prefer. But I'm getting 2.8074. They asked for 4 decimals on that. Okay. Or you could do log base 5 of 89, right? So just ln 89 over ln 5. This gives you 2.7889. Okay, this next one's interesting. I learned a long time ago that when you're given an awkward base, you can actually square it if you wish, as long as you square the argument at the same time. So watch this little trick. This is a trick I made up. You can square this and this at the same time, and it does not change the question at all. It gives us log base 2 of 5, which I think I already answered earlier, but I can't remember the answer. 2.3 something. The answer is 2.3219. So that's a nifty little trick. Or you can just type ln root 5 over ln root 2 if you feel like you want to type that. I just thought that was a cool trick. So what I do, I squared the base and I squared the argument at the same time, and it does not change the problem at all. And I can prove it, I just don't have time right now. Okay, the proof's actually really simple. Let's go to the next one. How would you graph this on your calculator, seeing as most of us don't have a log base 2 button? Well, you would actually type this as ln x over ln 2, and you'll be able to see the graph that you drew on your note card, or that you'll be drawing on your note card on for Tuesday. You're going to be graphing this graph Tuesday. You can check your answers on your calculator if you know how to type it. All right, let's look at the next one here. Express y as a function of x. Well, let's move this 2 real quick. So we have ln x squared minus ln x plus 1 plus ln c. And this all collapses into a single logarithm, cx to the 7th over x plus 1. So what just happened? Oh, I'm sorry, that's an x squared, isn't it? I can't even read my own handwriting. This is supposed to be an x squared, sorry. So how did I do that? Well, I knew that the ln x squared plus the ln c would give me ln cx squared. And then the fact that we had a subtracted log means that you're going to have a denominator, x plus 1. And I gave you permission to cross out the logs whenever you're given log of yada yada equals log of yada yada. So you can just kind of cross those out, and we get y is cx squared over x plus 1. Okay? So that's my answer, y as a function of x. And this one's for fun. This is a cool example. I told you that if you don't like the base you're given, there is a way to change it. In fact, we've been typing some of these things a moment ago. But isn't it true that I could technically make everything a single base if I wanted? I could make everything log base e if I wanted, if I follow my little change of base rule. But what I'm going to do on this is I think I'll just write this as log 4 over log 2. So that's in base 10. What would the second one be? Log of 6 over what? Log of 4. And what's the third one? Log of 8 over log of 6. Oh, look at that. Some of this stuff cancels out. That's kind of cool. Like the log 4 cancels, the log 6 cancels, and you get log of 8 over log of 2. Isn't that the same thing as log base something of something? What is it the same as? Log base 2 of 8. And isn't that just a number? What power of 2 makes 8? 3. That's a fun problem. I like that one. Did we finish?
Yeah.
Can't believe it. Okay. Alarms and all. Did I record it? Yes.
You got